All right, welcome back for 2-4 part 2, where we're talking about the slope of a line parallel to a line, but this time we're just given the equation. So maybe you remember from Algebra 1, y equals mx plus b. And remember that m is always the slope and b is always the y-intercept. So this particular line right here, if I were to sketch it, would have a y-intercept at -4, because it says -4 there. And then it just says negative x. So remember that's like -1. So I would go down 1 over 1, and this would be my line for this one right here. If I'm wanting something parallel to it, I need the exact same slope. So the first part looks the exact same. And then I pick any number in the whole wide world because they're all going to be parallel. So like if I chose +1, means I would go up 1, down 1 over 1. Notice these lines are parallel. I could also choose y equals -x minus 2. Y-intercept at -2, down 1 over 1. Also parallel. All three of those lines are parallel. All right, what about perpendicular though? All right, so 2, 3, 4, 5, 6, 7, 8, 9. All right, so for this one, I would go up 6, 1, 2, 3, 4, 5, 6 for my y-intercept. I would go up 3, 1, 2, 3, and over 4, which puts me way over here. Now remember, for perpendicular, we need the opposite reciprocal of 3/4. So first thing I'm going to do is flip the fraction, and I'm also going to make it negative. So y equals -4/3 x, and I can make any y-intercept that I want. So let's say that I make it +3. That means I go up 3 here, then I go down 4, so 1, 2, 3, 4, and over 3. Now, my graph is not proportional, so that doesn't look perpendicular at all, but if you go on Desmos and graph this line and this line, you should see that they make a 90-degree angle. So what if I got a little more specific? I said, all right, I want you to write an equation of a line that's parallel to this equation here. But this time I'm going to be a little more specific, and I want it to go through the point 2, 2. What I'm going to do is use this formula here. This is called point slope. It's a very handy formula. This is x1, this is y1, so where there's an x1 I'm going to put a 2, where there's a y1 I'm going to put a 2. I'm going to bring down the x, bring down the y, and then I have to look at the slope. What is my current slope? Well, it's this -1 out front, and to be parallel it has to have the same slope. Okay. If I want to get it to look like y equals mx plus b, I'm going to distribute that negative sign. So negative x, negative times negative is +2. And then last, I'm going to add 2 to both sides to get y by itself. So I get -x plus 4. We're going to practice that one more time with perpendicular. So if that was a lot, I got you. Okay, so perpendicular, we're still going to use that same formula. This time we're going to go through the point 0, 1, and we're going to have to change the slope a little bit because it's perpendicular, not parallel. So with parallel, we just wrote the same slope again, right? But perpendicular, we need to first change the sign. So it's currently negative, so our new one's going to be positive. And then we're going to flip the fraction. So 1/2 flipped becomes 2 over 1. But 2 divided by 1 is just 2. So that makes my life easier. I don't have to deal with messy fractions in this problem. Okay, I'm going to bring this down. I'm going to distribute. So 2 times x is 2x. 2 times 0 is 0. So put a 0 there. Last step is to add 1 to both sides. So I get y equals 2x plus 1. And there you have it. That is all about parallel and perpendicular lines.